So we're going to be talking about data type usage. This session, by the way, I created quite a while ago. It's gone through a few minor revisions, but it is so pertinent year after year after year. I'm going to skip over these things. Those are all the SQL, the past Summit things. But I do want to point out about me. My first PC had a 10 megabyte, not gigabyte, 10 megabyte hard drive. So that just shows you how old I am. Actually, you're right. My first computer didn't have a hard drive at all. It was all keyboard entry, and it was gone as soon as you turn it off. That's a different story. Yes, programmable EPROMs. Yeah, yep. Yeah, that was an add-on. Okay, so this is what we're going to cover. We're going to talk about why we care about the various data types and data type usages. We're going to go through not every one of them, but I'm going to touch down most of the more commonly used data types. And many valuable things will come out of what I'm referring to as the functions and nuggets. There's functions that are good to use and bad to use, and then other little tricks that you can take home or take to work and do a better job. By the way, every time you see a red dot, that's a note to me that I've got a demo. So if I go past a red dot and don't do a demo, yell at me. So why is data type usage and choices important? Well, accuracy is one of the two main reasons that I'm covering. And this is just kind of a little teaser that I'm showing. And here I'm creating 6 variables. 2 of them are decimal data types, 2 are money, 2 are float. Within each data type, I have a value of 1 and a 3, 1 and 3, 1 and 3. And then I'm going to do 3 calculations. I'm going to take 1 divided by 3 times 3. Well, everybody knows that 1 divided by 3 times 3 is 1, right? But based on your data type usage, you can get, whoops, I hit the wrong button again. You can get the wrong answer. And notice right here, the money gave us a rounding error. And we'll get into a lot more detail why that happened, how to minimize rounding errors. You can never totally avoid them, but how to minimize them. Performance is the second reason. I always think of there's 3 pillars to any code design or architecture or anything. Accuracy is in most environments critical. You have to be accurate. There's some exceptions. Performance, if it's not a problem now, it will be a problem soon. And the last one is maintenance, which I'm not covering here, but those are the 3 things that you typically think about when you do development. Performance is right up there as close to accuracy as you can get. Many performance benefits of using the right data type. So show the actual, who uses actual execution plans? Who looks at execution plans? Okay, 2/3, 3/4, yeah. So the execution plan tells you what SQL Server is doing inside to execute a query. What I'm going to do here is, I'm starting out, I'm just creating 2 tables. I'm calling them decimal 1 and decimal 3, or decimal 2, decimal 9.3 and decimal 29.3. Same data type, but different precision. And then I'm going to insert into them, both of them, the same thing, 500,000 rows. I use a utility numbers, a tally table, some people refer to it. I always have one of these. And then I'm going to take a look at the storage used by those 2 tables. And why is storage important? Because when you query the database, usually the most significant factor is I/O. How much time does it take to get the data, not necessarily CPU and network, all those come into play. I/O is usually the most significant. The larger the table, the larger it takes up in disk space, the more I/O you're going to have with the query. And then I'll have a query to actually show you the difference in performance. So I'm going to load 500,000 rows into both of those tables. And then I'm going to query sp space use, which simply shows how much space is used by those 2 tables. And here's the key thing. The reserved amount, notice that the second table used almost twice as much space to store the exact same data. The data is the same in both of those tables. It's a different data type, different precision of the data type. And to show that that in fact does impact performance, here's a query that I'm going to simply query from both of those tables. And I'm going to have one predicate of where the column is equal to 1 for both of them. There's decimal 1, decimal 2. And I'm doing a timestamp in between them so I can see the duration of each of those. And I'll also look at the execution plan. And when you execute that, first of all, down at the bottom, the duration, slight difference. Sometimes I see more significant difference than that. Often I do. This is a pretty small query. Here's an important one. So by the way, set statistics IO on is a very common first step of performance tuning because among other things, it'll tell you the reads. And there's a lot of information here, but usually the most significant is the logical reads. And notice right there that I had to read almost twice as many pages, 8K pages, to satisfy that second query, the one that had the larger data type. Same exact data, just a different data type. And to show one other way, oh, that's in the same place. The execution plan. This, by the way, if you use execution plans, one of the first things that most people look at is when you have more than one query, it will show you the relative cost in the batch. Treat that with hesitation. It is sometimes a good indication, often it is totally misleading. In this case, it's relatively close. It says the first query is going to take 41% of the time, the second one 59%. So all of that indicates that simply by changing the data type, the precision in this case, we've got different performance. Sargeability. Who knows what sargeable is? Searchable argument. This right here in my whole presentation, if there's stuff that you can learn and go back and be a hero, this is it. And I've tried to figure out how to put it late in the session, but it just fits so well here that that's where it's going to be. So sargeability and implicit conversions together. Sargeability says in a predicate is one of those things that says that it returns either true, false, or unknown. And usually it's in a where clause, where this column is equal to 6, that's a predicate. Where this column is greater than that column, that's a predicate. A join clause on this primary key is equal to that primary key, that's a predicate. Basics of sargeability says statistics and indexes cannot be typically used unless a column in a predicate is by itself on one side of the comparison operator. Column equals 5. Any statistics on that column can be used, and any index on that column can be used. The optimizer may not, but it's open to be used. So it's really important in any query that you write that you try and get columns by themselves on one side of the comparison operator. To show you that, here's a couple of simple queries. I have a very, oh, by the way, this is SQL Server 2016, and I'm using AdventureWorks 2014. That really doesn't matter that much for what I'm doing, but you should get very similar results on 2012 or 2017. So a variable called I that is get integer, and it's equal to 2. And then I'm going to have two queries, and again, I'm going against my tally table, numbers table. The first one says where the number is equal to this variable plus 1, so that the number is equal to 3. And the second one says the number minus 1 is equal to the variable. So the same thing, the number is equal to 3. And if you know math, you can put things on the other side of the equal sign and change the sign, and it's equal. So those two are logically equivalent. But the first one has the column by itself on one side of the comparison operator, and the other one doesn't. The first one is sargeable, the second one is not. When I execute these, and I'm going to execute them with this, okay, that's not very good. With this, where I'm going to, first of all, I'll set statistics IO on so I can see the pages that are read in order to satisfy the two queries. And then I'm going to do statistics and execution plans, and you can see huge differences here. So I'll execute that just simply to okay, so this, I'm sorry. So this one, this is where I executed. The two are sargeable. Notice that they have, or the first one is sargeable, the second one isn't. They have the same answer. Look at the statistics. Exact same logical query. Look at the difference in the I/O. Huge, huge difference. Can you see that in the back? And the execution plan is also quite similar. If you know much about execution plans, generally a seek is good and a scan is bad, generally. And this one has a clustered index seek, and this one has a clustered index scan. And also notice that it decided that it was going to be 0 and 100%. There's a huge difference between those two queries. Logically identical. All I did was I put the column by itself on one side of the comparison operator. So here is one. Oh yeah, this guy. I have 3 examples, I think. Yes, I do. So in this case, this is where it looks like it's sargeable because where the sales order num is the column is equal to that value, or the sales order num. But I have 2 different variables of 2 different data types that I'm comparing. So I'm going to select from the table where it's equal to the varchar variable. Who says varchar? Who says varchar?
I say varchar because Vern.
Yes. Or varchar. It's variable character. So to me, it's varchar. But okay.
It looks at me funny when I insist on doing
I know. Everybody looks at me funny too. So, what's that? Right. So in this case, we have a sales order number equals to a variable that's a varchar, and this one is equal to an integer. So in both of these cases, the column is by itself on one side of the comparison operator. So it looks like it's sargeable. But did you know that SQL Server cannot directly compare 2 things that are different data types? Can't do it. It has to convert one to the other. And that's an implicit conversion. And there's a set of rules of when 2 different data types, which one it converts to the other one to do that comparison. So one of these doesn't need the implicit conversion because it has the same data type as the column. The other one is a different data type, and the SQL Server says, oh, I can't compare these 2. I have to convert one of them. And it looks down its list of the order, the precedence, and it says, oh, I'm going to convert the column to the data type of the other one. When you convert a column, that's, even though it's implicit, even though you don't see it, it's a cast or a convert around that column, and that column is no longer by itself on one side of the comparison operator. It looks like it is, but that hidden, invisible, implicit conversion is making it non-sargeable. So those 2 look really good, but when we execute them, almost 10 times as number of reads on the second one, so guess what? The second one had the implicit conversion. And looking at the statistics, the execution plan, and I can't see it all because I need to go up here. There we go. Notice here we have an index scan and an index seek, and there's one other hint that I don't want to go into a lot of detail on, but see that little yellow exclamation warning sign? If I open that up, that's going to tell me I had an implicit conversion. That's exactly what it's intended for. It's to warn me when I look at this, whoops, I have an implicit conversion that may or may not, in this case it did, affect my performance. The query optimizer had to guess at how many rows it came up with the wrong plan, not the wrong, it didn't come up with the optimum plan. One more example, and this one, I just threw this one in because I see this so often. Here's 2 different, almost identical queries. I'm going to look for the person that's last name starts with M-U-R-R. They're both the same, but for some reason somebody thought, you know, I think there might be some leading spaces on the name, so I'm going to do an L-trim. Notice right there now that that column is not by itself on one side of the comparison operator. That, either in index or statistics on that column, can't be used here, but it can be used here. They look identical, the second one is a problem.
Wouldn't it make more sense to have two queries that are equivalent?
I can't see where? Oh,
Wouldn't it make more sense for the upper one to be percent M-U-R-R percent? To make them equivalent?
other than the L-trim, I'm not sure how they're not equivalent.
He's suggesting a look for your first query.
The one at the top. And it's also not equivalent. It's not equivalent to the one at the bottom.
He's just saying that because the assumption is that you got a space at the beginning, and then you wouldn't have had it would be space M-U-R-R if there was really a space. You're just showing.
I'm just showing that an L-trim destroys sargeability.
Right. You could change
Yeah.
it to left with a 4, and then it would have been
Oh, no. If I put a left around it would,
the bottom one.
if
Change
I,
that from a left trim,
an L-trim,
yeah, to a left
Okay, carry on.
with a 4 in there, then you would have gotten,
around the last name,
make it equal, and then you would have had the same type of,
same kind of a problem. If I put this left last name 4 is equal to M-U-R-R, exact same thing. The left is a function, and the column is within that function, and it's no longer by itself on one side of the comparison operator. So same exact thing. So when I execute this, and again, we have some significant differences in I/O, and as expected, I didn't put a timing on it, but it did take a lot longer, and the execution plan also shows, I hate it when I do that. Execution plan shows a clustered index scan versus an index seek. So,
if you had a select where
can you hear it?
percent were percent, how would that compare? It would be equivalent to the last one.
Okay, so if we had what here?
If you had a third query
Okay,
and you were selecting from with the same
okay. And then here?
instead of saying L trim, you took out the L trim and you added another percent sign at the before the M in MER.
Okay, so if we put a percent sign at the beginning of the MER, that would be sargeable, but you avoid the use of any index when you have a leading wildcard. So it's a different kind of a performance hit, but it's a performance hit nonetheless. Right, because you couldn't use an index or statistic if you had a leading wildcard there. It just has to scan, no choice. Okay, where did that go? There we go. So again, I'm more than happy to spend more time on this. This to me is by far the most valuable, useful bit of information out of this. Implicit sargeability, implicit conversions, destroying sargeability can really, really help. It was just a few months ago, one of my contracts, I was looking at performance tuning one particular query, and I noticed they had a view and a single predicate, and the predicate was not sargeable. I mean, it was just a real simple thing. And it was very much like my example where there was an L trim and it didn't need to be there. I changed it. That one view not only improved a lot, but what turned out to be a view that was used hundreds of times every day. So all of a sudden, many of the processes sped up from that one sargeability discovery. It can really pay off.
We did the same thing with times, and then we try and translate them to Eastern Standard or UTC.
Times is, yeah.
And everybody wants to translate the database column, so you do the translation now. So just translate the other.
I just went through a significant sub-project that all had to do with UTC for everything, because it was around the world, and all that you have to do with time zones and daylight times, and it's amazingly complex. So I mentioned that when you have two different data types that need to be compared, that one has to be converted to the other. This, out of Books Online, is the rule of which one gets converted to the other. So for instance, if you have a date and a character, then the character gets converted to the date. So the higher number gets converted to the lower number. So when you're converting a string to a number, the string is going to get converted to the number, because the number comes first. Okay, now we're going to go into the various data types, and they're in categories. These are the main categories: numeric, character, temporal, which has to do with time or date, and binary, and then the catch-all category of other. This slide, I've had this slide on my computer now for a long time, and it's amazing how often I look in here and say, how big can a big int go? Because I can't remember those numbers. So I just open up my slide deck and go to that slide. Oh, there it is. So that's just a nice reference of what capacities each data type is. What?
2 billion, 2 billion.
2 billion, 2 billion. Well, yeah. So here's some numeric data type issues. First one is float and real are imprecise by definition. By definition, they're imprecise. They are not intended to be accurate. And that can show up in so many different ways. So I'm going to create two tables. And let me just highlight the whole thing. So two tables, one of them called I and the other one called R, and the first one is going to have an I single column that's an integer, and the other one R, which is real. So two tables. Then I'm going to insert into the I, what is there, 8 different values, 314, 159, 263, 264, 265, up to 270. And then I'm going to, into the R table, I'm going to insert 1, and that 1 right there is going to match this one. So I have 8 in the first table and 1 in the second. And this matches 1 and only 1 of the records in the first table. Okay? Then I'm going to do a select. Let me just do that first. Then I'm going to do a select from the I table. That's the one that has the 8 values, where its value, its one column, is equal to, and then I'm going to sub-select the one row out of the R. So there's one row in R, and it is equal to one of the rows in the I. And so this should return one row, right? Any guesses? No rows. Well, let's see. Oh, returned all 8. Different data types. So what is happening? Well, what's happening is, again, an implicit conversion. And this is really what's happening. Remember, you can't compare, SQL Server can't compare two different data types. It has to convert one to the other. So what it does, it says, okay, I have a real coming out of this, and I have an integer here. I have to convert one to the other, and if you look at that list, it's going to convert the integer to a real. And when you convert all 8 of those values from an integer to a real, the value is exactly the same for all 8. Because real and float are imprecise. So this gives us the exact same end result, gives us all 8 records. What we probably want to do, is this. We want to explicitly convert that R, that real value, to an integer and then do the comparison. We want to tell SQL Server which one to convert to the other. And that's a good rule to follow. Anytime you're comparing two things that are different data types, you decide, and then you're aware of what's going to happen because of that decision, but you decide which one gets converted. So when I do this one, it's going to give me the one value as I expected. Guys are awful quiet. I know I'm going kind of fast, but yes?
Why would we have the imperfect floats?
Well, I can't come up with a good use case for why we have the real, but the float can go to extremes. If you want to measure the distance between here and the sun in inches, you can do that with floats. You can't do it with any other data type. If you want to measure the diameter of an atom in miles, same thing. You can use a float, but you can't use any other data type. So extremes of numbers, that's where float comes in. Real is just a smaller version of float. I'm sure there's cases I've never used or never had a reason to use a real data type. So my rule on real and float, unless you're going to measure distance to the sun or something, don't use them. Okay, money has some rounding surprises. Remember that example that I had earlier? Well, we're going to go into a little bit more detail of that. So first of all, I got rid of one of them. Which one? I got rid of float because we already determined we don't want float. So I just have decimal and money. And when I do this calculation, remember the money gave us the rounding error, 0.9999. And there it is. So the question is, why? What happened here? Why did one give us a rounding error and the other one didn't? Well, there is this built-in function called SQL variant property. SQL variant is a data type that's rarely used, and this function is intended to help someone use that data type, but it's also useful for non-SQL variants. So in this case, I can say, here's a variable, and I can use this function to tell me the base type of it, tell me the precision, and tell me the scale of it. So I can use that function for things other than SQL variant. That's really helpful. So I'm going to create this variable that's a decimal 9, and I'd better see decimal 94, and then money, because what is the base type and precision and scale of money? Well, let's see. So when I execute this, decimal 94 as I defined, but notice that money is a 19.4. Now that's important, but the other part that's important will show up in the next one. Money is always a 19.4, whereas decimal can change. So in this next example, I'm going to do my calculation, and this big query here, first of all, will show the variant property of the result. Well, first of all, show the result, and then I can not only show the precision and base type and scale of a variable, I can show it of a calculation. So here I have the calculation of 1 divided by 3 times 3 for the decimal, and I can take a look at the base type, precision, and scale, and then this bottom half I can do the same thing for money. So I can see what is the precision scale of that calculation. And when I execute this and look at the results, I have an accurate result with the decimal. And this is the result, this is the output of the SQL variant property. And the data type of that calculation, the output of the calculation, is decimal 38.6, even though I started at 9.4. So decimal increases the precision and scale with calculations in order to be able to hold the answer accurately. Money is stuck at 19.4. So as soon as you start multiplying or adding or doing any math at all with money, you have the potential of a real early rounding error because it can't get any bigger to hold a bigger result. And there's quite a formula, a rule, I guess, on books online. This is I got to memorize this, everybody. This tells you if I start out with a decimal and then I add two of them together, what's the precision and scale of the result, and divide all of these different things, and this tells you, that tells you how SQL Server determines the precision and scale of the answer, of the result. So even though money has what I refer to as early rounding errors, any data type has potential rounding errors. They just don't happen as soon as they do with money, which, by the way, my other recommendation, unless you need to recognize in a string a currency character, such as a dollar sign or euro sign, something like that, unless you need to do that, don't use money or small money. Use decimal.
Well, sometimes money is the right answer because it's intended to truncate it to, after a decimal.
But you can do that with decimal, and you, at the same time, delay rounding errors.
Well, in a long calculation like that,
Any one calculation.
we've had the errors where our calculations are more accurate than the accountants wanted.
That says a lot.
Because
Don't-
we're off by a penny that we got to go back and figure out why.
More, I'm repeating for the microphone. You had errors from using decimal because the accuracy was more precise than the accountants wanted. I've never encountered that. That's a good one.
Where did the accountant go?
Yeah, right. He left the room. Okay. More rounding surprises. So here's one that I like. So I'm going to create two variables. One I call small d, that's a decimal 2-1, and the other one's a big D, decimal 9-1. I'm going to give them the same value, and then each of them it runs off the screen, but I multiply them by themselves, I think 10 times, the same number of times. So it's almost intuitive that you think, well, if I have a bigger capacity, that's got to result in more accuracy. But in fact, it's just the opposite. So when I execute this and look at the results, notice that I go all the way down to, I don't know, 10 decimal places when I started out with a smaller scale or precision, and then I start truncating because I started out too big. So the rule here is that size matters not only for performance and I/O, those kind of things. Don't make your data types any bigger than they have to be because you can run into problems sooner. And I think, yes, I do. I'm doing the same thing using that SQL variant property to take a look at the precision and scale of the output of the calculation. And for the two values, there's the calculation, and then these three rows are displaying the data type of that calculation. And you can see there, notice that this is decimal 38.6 when I started out with a larger precision, because remember that as you do calculations, the precision and scale gets bigger to hold it, but it can only get so big. And with decimal, it can only go to 38. And as soon as it hits 38, and remember it's expanding on both sides, the precision and the scale both expand. When it hits 38, that can't go anymore, so the scale starts to shrink down, and that's why it's 38.6. But in fact, the calculation actually gave us numbers all the way out to 10 decimal places. So it still comes back to this calculation that it's got to expand, but a different manifestation of what happens when you pick the wrong size, in this case of the data type.
What would happen instead of just letting it do the calculations and the select and give you the display is if you did a third data type of number 29,6, and then they both put the results into that.
If it was 29.6, then both of them would get truncated going into the
Well,
other data type.
that's what the thing showed it with the 29.6 that it needed. to do.
38.6, yeah.
Okay, so if you had that same data type as your third variable, and then you said select that variable equals the results, and
Oh.
then you select that variable, see what your data type
The variable wouldn't change.
I know it
Yeah.
wouldn't, but see what the results would be stored in it.
Don't have enough time to do it now, but okay.
All right, you see what I'm getting?
Yes, I do. Okay, next one's a character data type. And here are the various character data types that are available. And text and end text are deprecated. Varchar max and nvarchar max do everything the text and ntext do, plus some. So not only don't use it anymore, if you are going through existing code, change it. Nothing to lose, a lot to gain. So a few things with data types in the character set. So size matters. So whether it's a varchar or a character, what about specifying small versus a large value, maximum size of a variable or fixed width data type, string data type? What is the differences? So turn off X. This one takes a while. I even have my note here. Execute while explaining. Okay, so I'm going to execute that. So while it's executing, we'll talk about what I'm doing. So two tables, I conditionally drop them. I have the same column in both of an of integer, and then I have a filler just to make it a little bit bigger, make it more realistic. And then the difference between the two is one of them has a varchar 60 and the other one has a varchar 2000. And then I'm going to insert into them number 1 through, what's that, a million? A million. I'm going to put in a million records in both. So the first column has that 1 through million value. Every single row will have 500 X's in the second column. And then an empty string into the last column, every one. And then I put an index on it. And lastly, I will take a look at the space used on that. And is it done yet? Not done yet, so I'm going to talk some more. Wait, I'm done talking. No, I'm not.
You could have made the drop table a little more clear with the drop table exists.
Yes, drop table exists.
Nice new thing.
Nice, yes it is. In fact, I mentioned that at the end. I have a last slide if we get to it of new features, and that's one of them, yes. Okay, it finished. So now I'm going to take a look at the space used of these two tables. What's interesting here is that the reserved is almost the same. So the leaf level of the table, the main data itself, is very similar. But what's different is the index size. Because when it fills in the non-leaf rows of an index, it considers the capacity of a varchar or character and will expand or contract how many rows go into those non-leaf levels based on that size. End result is we have 50% or thereabouts more space used in the non-leaf level. This particular one is not going to be a killer for performance. I mean, it's not going to all of a sudden go from a second to a minute. But it will have an effect. Small as it may be, it will have an effect. So size does matter. And to me, although performance could be impacted by this a little bit, to me, this is a bigger reason to not make a data type, character in this case, larger than it needs to be. Data types, among other things, maintain your data domain. If I have last names that my business says will never get a last name more than 60 characters, why would I make a varchar 100 or anything larger than 60? If it's not supposed to be in there, then that's one minor thing I can do to enforce it. Use only the size that you can confirm is all that's needed. How about varchar versus notice that I don't have a number here after this, and I do have it here. What happens if I don't specify the size of a character or varchar? What's that? 1? Really? Always? That's a trick question. See what? No, but you're kind of getting close. So the first thing I'm going to do is I'm going to just create a variable, and I'm going to give it a data type of varchar without specifying the size, and then I'm going to stuff into it 100 characters of the letter A. And then I'm going to use my wonderful SQL variant property to take a look at that variable and see how big it is. And when I do that, I have one character, and sure enough, it's a varchar 1. So with variables, if you don't specify it, it's one character. Next, how about a table? Okay, I'm going to create a table. Go through several steps here. I'm going to create a table with a single column called C. It's a varchar without specifying the size. And then I'm going to insert into it that same thing, 100 A's. Well, I should have stopped my highlight there, because what happens is that errors. It says, nope, I can't put those 100 A's in there. It doesn't fit. So I said, OK, I know it's got to at least accept 1. So I'm going to create the table again, this time with it as a varchar. I'm going to insert into the table just a single A, and then see the data type. And sure enough, same thing, one character. So table column definitions, if you don't specify the size, it's one character. OK, last one is a cast. If I cast something, I'm going to cast this replicating A 100 times as varchar without specifying the size. And then I'm just going to take a look at the property of that same thing. Any guesses what it's going to be? No? Not one. No, it happens to be 30. Of course. And you know that's right because it's documented. So therefore, it must be right. That's right out of Books Online. It says default length is 30 if you don't specify it. So the rule is not to remember that this one's 1 and this one's 1 and this is 30. The rule is always specify the size. You can scratch your head for a long time, yep. So how about varchar versus char? I have quite a demo on this, but it's too time consuming to do. So years ago, my rule of thumb was if it's really small, like 5 characters, something, use a character. You know, a character is fixed width. If you have a character 10 and you put an A in it, it's going to have A plus 9 spaces. It's going to use up that full space. Whereas varchar will shrink and expand as needed, but it has a little bit of overhead to do it. So there's some give and take. So I always thought that if it was really small, 5 or 4, and relatively consistent length of your data, that go with the char. Other than that, varchar. It turns out that it depends, but in my tests, much higher than that. The exact test that I did came up with somewhere around 15, 16 was the trip point. It takes way too long to run, but the point is that your situation could be different. Do some tests to determine where you want that breakpoint to be and determine whether or not you have character or varchar. So no demo on that one. How about varchar n versus varchar max? So when would you use varchar n, specifying the size versus just saying max? Less than 8,000. Yeah, 8,000 is a maximum. So, but if you're less than 8,000, why wouldn't you use max? So my first thought was performance, and I started to do some testing, but one of our other local guys, Rob Garrison, did a very thorough test on it. And his conclusion was, it depends. But generally speaking, they're so close that you can't really say that one was faster than the other. But I come back to my standard, domain integrity. If you only need 3,000 characters, don't use varchar max. Use varchar 3,000. Don't go any larger than you have to have. If you have to have over 8,000, then you have no choice. You have to go with max. Yeah.
Can you not fast load?
What's that?
Fast load?
Fast load, I'm not sure, but I think you're right. Yeah, some bulk loading stuff. I'm not positive, but yeah. Okay, I'm squeezing in here. I'm almost done. Temporal category. This is my favorite, and I've got 10 minutes, 15 minutes worth of stuff. Oh. So temporal having to do with date time, these are our data types, and by the way, when they came out with the date, I loved it. Love the data type. Use that all the time. So in here we have the small date time and date time. I have them crossed out. They are not officially deprecated. At least I haven't found where they are. Maybe they've done that by now, but I haven't found it. But Microsoft has stated don't use them for new code, and there's good reason for it. Isn't that the definition of deprecation? Not really, but deprecation says we will be dropping it.
There's way too many apps out there that have old code that
Yeah.
Microsoft has to support.
Yep. So, a few things. Yes. Don't use date time or small date time. Use date time 2. Date time 2, you can specify the precision 0 to 7. In most cases, storage is smaller. Many other advantages. Any risks? Yes. And I'll cover at least one of those. They are different, and depending on what you have coded, I would say that if you're following the ANSI ISO standards and not getting out, undocumented stuff, you are probably pretty safe. But there's some undocumented stuff that a lot of people do that can break when you convert to date time 2. Yes.
Real quick on the date.
Date.
You can do some special type of stuff with date. You can take a float and convert it to a date because it's in seconds and stuff like that. If that's your base, you can take also a 0 as your default value for a date that will take you back to the 1900. You can't do that type of stuff with date time 2. It has a different base format.
So I cover a lot of what you're saying, but you didn't quite quote it right. Date time and small date time you can do those things with, not date or date time 2.
I'm sorry.
Yes.
I was looking at the ones crossed out.
Yeah, I'll be covering quite a bit of that actually,
Translated differently.
time permitting. Okay, date literal. So somewhere along the line we need to type in, or maybe we get a file that we have to import that has a string that is a literal that we need to convert to date. So one of the questions that comes up is what's an unambiguous way of specifying a date? How about any of these? Anybody have any comments on whether or not these are all ambiguous or unambiguous? The bottom one is not ambiguous. The other two are ambiguous.
I take the hyphens out.
So it's Pentagon insists on taking the
Well, it's not, as you'll see, it's not just ITSIC. It's specified as such. If you want total unambiguous, or, yeah, whatever the word is. So do I. So I've got a few tests here, and all I'm doing is I'm changing the language to British and then to English and seeing the result when I convert that string. See, there's one string, here's another string, and by the way, this is really funny because just yesterday I was signing a bunch of papers and putting down the date, and I have a habit of putting down a date in my way, which is none of these. And someone commented on it, and I said, well, as a matter of fact, 9/12, well, okay, the year is different, but that's exactly what yesterday was. Anyway, so here I'm converting these to date time and to date, and seeing which ones convert unambiguously. And notice that the first two are December 9th and the second two are September 12th. So US does it one way, the British do it another way. Here's another one. This is, what's that? Yes. Yeah, I like that. 2 countries separated by a common language. Oh, Mark Twain? Okay. I like most things he says. So here's another one. Same idea. I just take a look at what this string converts to for both British and English. And again, very similar, Decembers and Septembers. And then this one, which by the way is the one that I tend to use a lot, this format, year, dash, dash, day. But when I execute that, it's even stranger in British. because if you convert it to one data type, it gets December 9th, but if you convert it to a different data type, it's September 12th. But still, it's not it's ambiguous. As it turns out, there are two different unambiguous ways. No matter what language you're using, these two are unambiguous. Get rid of those dashes, but I don't find that very readable. And remember that the dashes are only a problem with the old data types. So if you can get rid of date time, then it's safe to use the dashes. The other one down here is the really verbose ISO standard, year, dash, month, dash, day. Capital T has to be there. Hour, colon, second, or minute, colon, second. All of those are required. So all of these are unambiguous. So they will give you the same answer in all cases. Okay. I'm running out of time. So let's see, what am I going to do? Okay, I'm going to cover this one. Skip that. Using between. And this is because this is one of the more common, and I just closed my window. One of the most common mistakes is starting to disappear, but it still happens. One of the problems with date time. So here we're going to make sure we're in English. We're going to have a begin date time that's the first moment of January 1st of this year. An end date time that's the last moment of January 1st this year. So I'm spanning the entire day, and date time only goes down to 3 decimal places. And then I'm going to have a test date. And my test date is the first moment of January 2nd, outside of that range of the first two. And then a simple test. If that test date is between those two, then I'm going to say in between. Otherwise, not in between. And of course, the first moment of January 2nd is not in between those first two extremes of January 1st, right? It's outside of it. Of course. And that's why it says that it is in between. Date time is a problem. And this is an example, or this shows you why that is. Yep, 3 1/3 milliseconds. So I'm going to create a table with a string data type and a date time data type. I'm going to start out by just simply populating the string data type in the table. And then I'm going to update it, setting the date time column to casting those string values to a date time, to its data type. And then I'm simply going to take a look at the result. And when I do that, notice some interesting things here. Notice this last column. Notice the last digit. 0033377770. Those 0, 3, and 7 are the only 3 numbers that are possible in the least significant digit of a date time. Look at this one right here, number 10. It took 11/59/59/999 and it rounded it up. And when it rounded it up, it went to January 2nd.
Angie, you're right. Oregonians round down, but software makes
Yeah. So the lesson here, don't use date time. And in fact, if you're on anything after 2008 R2, when did date come out? I don't know when it came out. R2, was it? Okay. Which means that just about everybody should be able to use date time 2 or date. And of course, the right way to do this is to say, is it greater than the first one, greater than or equal to the begin date, and less than the end date, and make sure that the end date then is the first moment of the next day. So that's the safe way to do it in any data type. Okay? Or what's that? Yes. And is there anything else that I really want to cover?
Isn't the point that
Here in our other category, the timestamp and row version. Who uses either one of those, timestamp or row version?
I've done it before.
So there's a lot of value to it, but the reason that the timestamp is crossed out is that here's another Sybase inheritance. Timestamp has nothing to do with time. It is not a temporal data type. And everybody else other than SQL Server and Sybase, timestamp is time. So it's extremely confusing. And so Microsoft has said, stop using the name timestamp, use row version instead. And that's much more precise meaning of what it is. So if you're using timestamp any place, change it to row version.
There's one interesting aspect to row version that gets overlooked often.
Okay, I'll quit.
Is that row version is this incrementing serial number database-wide. So if you add row version to multiple tables, you can sequence things by the row version number. You can sequence every activity in the database with row version.
So I'm running out of time. I've run out of time. So the only thing I'm going to say.
Yeah, thank you.
So don't have time for the demos. Is numeric. Simple thing about that. Avoid it like the plague. Do not use it. Do not use is numeric. Period. Many problems. Try convert or try cast instead if you can. Is date is not as bad as is numeric, but it has similar problems having to do with the fact that it's a date time, not a date time to function. So avoid that. Again, try cast or try convert is the better choice. And that's isNull and coalesce are very similar. An important thing to remember is that the data type that it returns is different. And I've seen code that works just fine. Somebody said, I don't like isNull, I like coalesce. They changed it, and all of a sudden it broke. By the way, that person was me. So be wary that isNull and coalesce, although they're very similar. Coalesce, you can have more than two arguments, but they do the same logical thing. Different data types. Be aware of the data type. Yes? Oh, no. Those are just the temporal functions. A quick summary of those temporal functions. The current timestamp and getDate are the same, although current timestamp is the ANSI ISO standard term. GetDate is SQL Server only. And it returns date time. GetUTCDate is UTC, but it's a date time data type. The other two, sysDateTime and sysUTCDateTime, they return datetime 2. So in that sense, they're better. There's no deprecation that I'm aware of. End of month, new function. I don't know how many times I've had to write, okay, here's a date. Okay, go to the first of the month, add a month, then subtract a day, and I got to the end of the month. Now we have a function to give us there. String split is nice, and Aaron Bertrand has done some testing, and it actually performs pretty well. Drop if exists, create or alter for system time. Those are all new functions in 2016 or newer. And I think the hook. Yep. See, there's a summary. Pick data types of consideration. Avoid deprecated data types. Implicit non-sargeable is super important. Okay? Thank you.